This is practice test number 13 on crackAP.com for AP Precalculus. This is hopefully good mock multiple choice practice. It's a comprehensive exam, so it covers everything on AP Precalculus, supposedly. Okay. It looks like it even includes the units that is not covered on the AP exam, because I see a matrix already right here. Okay, so if you're able to identify those, maybe you can skip those if you don't need it. As I was filming on this video, I don't believe matrices are in the AP exam, but could change whenever you're viewing this. But anyway, okay, let's begin. Number one, what's the numerical coefficient of the term containing x cubed y squared and the expansion of x plus 2y to the fifth power? Okay, so the website actually gives solutions. I might approach this a bit differently. And I'm going to solve these live to show you my thought process, okay? I have peeked at the questions and peeked at some of the answers, and there's actually one that's incorrect as well, so I'll point that out when I get there. Okay, so we definitely don't want to expand this one manually by foiling that out, and then we do it next with another x plus 2y. We don't want to do that 5 times, okay? Instead, what can we do? Well, remember the binomial theorem or Pascal's triangle? We can do either one. When we have a plus b to the n power, remember this triangle, Pascal's triangle? If n is 0, n is 1, n is 2, this is where your perfect square comes from. Not perfect square, the special a plus b squared is a squared plus 2ab plus b squared. The coefficients are right there. Okay. Oops, I expand the screen a little bit. That's fine. And I should be, I think it'll cut off. Okay, so let me, sorry, technical difficulties. Let me redraw this. Okay. Sorry, okay. Let me start from scratch again. Okay, so we have 1, 1, 1, 1, 2, 1. This is this for n equals 2. This is 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. Okay, so this is n equals 5. So we're going to use these as our coefficients, okay? Now, how do we expand this out? Well, we have a and b, so a is x, b is 2y. Okay, so basically, the very first term, you take the first coefficient, which is 1. You exponentiate the a, in this case, x, to the sum of these two, or sorry, this guy would be fine, to the fifth power, and 2y to the 0 power. You want these two powers to add up to that power over here. All right? And then the next term, we take the next coefficient, which is 5. It'll be x to the fourth, 2y to the first. All right? And then the next term would be, we take the next coefficient, 10, x cubed, 2y squared. And if we distribute these exponents, we get the x cubed y squared that we need. So what is the coefficient? That would be a 10 times, we distribute that squared to the 2, we get a 4. So it would be C, 40. This is one way to go about it. If you remember the binomial theorem, where it says that these coefficients, this 10 is actually, it will be, should be 3 choose 2. Sorry, not 3 choose 2, sorry. It would be 5 choose 3. I don't know why I did that. Okay, there we go. Struggling to write it. 5 choose 3. Okay. So then, how do we do 5 choose 3? It is 5 factorial over 3 factorial, 5 minus 3 factorial, which is 5 factorial over 3 factorial, 2 factorial, which 5 times 4 times 3 factorial is on top. And then 3 factorial, 2 factorial. So these 3 factorials cancel. We get 20 over 2, which is 10. Exactly the coefficient that we had over here. And then we still have the times 4. Okay? So that's the other way to go about it, the binomial expansion. Okay? All right. What is the inverse of the matrix 4, 2, 1, 3? So if you remember, there's a quicker way to do it for 2 by 2 matrices. Again, this is probably not on the AP exam, as I'm filming this video anyway, but I'm still going to do it. I'm probably very rusty on this, but I'm going to try to do it, okay? So there's a quick way to do it for 2 by 2 matrices. You have to like calculate the determinant, and then you flip some terms and add some negatives, if you remember that. If you don't remember that, we can always do reduced row echelon form. I believe that's what it's called. I don't teach linear algebra often, if at all. So this is very rusty. So you put the original matrix on one side, the identity matrix on the other side, and basically we want to change this left-hand side to the identity matrix, and whatever's left over here is our inverse, okay? So what can we do? We can do row 1 minus 2 row 2. We can store that into row 2. So the top remains the same, okay? And then it becomes 4 minus 4, which is 0. And then 1 minus 6, which is negative 5. Okay? And then 1 minus 0, which is 1. And 0 minus 2, which is negative 2. Okay? And now from here, let me erase the triangle up here. Try to get, okay? Can we do next? We can make this minus 5 over here a 1. So what do? We would divide by negative 5, right? So it becomes minus a fifth over here and 2/5 over here, okay? And then the top remains the same, okay? Let me rewrite the 1/5. We could probably actually from here start looking at the answers. It would probably be choice D, because here's the minus 1/5, it's just not simplified, and here's the 2/5, which is not simplified, okay? This is a multiple choice tactic. It could possibly trick you and mislead you, but doesn't seem like there's any other choices. So in the interest of time on the test, I would just come back to it later, especially for these time-consuming ones, but I'm going to continue, okay? So what else can we do? We can do row 2 minus row 1, store into row 1. All right, so then the bottom remains the same, minus a fifth, 2/5, and then I get 0 minus 4, which is negative 4. I get 1 minus 1, which is 0. Minus 1 minus 1/5, minus 1, that is minus, what is that, 6/5? And then 2/5 minus 0, that's 2/5, yeah? And then, let me go from here. We can just divide row 1 by negative 4. So we get 1, 0, 0, 1, the identity matrix on the left-hand side. And when we divide by negative 4, we get 6 over 20. And we get negative 2 over 20 minus a fifth and 2/5. Okay, does that match that answer? It does, because we can simplify this 6 over 20 to 3/10, and this minus 2 over 20 to minus 1/10. Exactly matches choice D. Okay. All right. Number 3, f of x is the sky, f of 1 is 4, f of negative 1 is 6. What is 2a plus b? Looks like we just need to plug in the values. So we would get 4 is equal to 1 cubed, which is 1, plus a times 1 squared, which is just a, plus b times 1, which is just b, minus 3. And we can simplify this to, this would be a minus 2 on the right-hand side. So 6 is equal to a plus b. We can even write, okay? And then, when we plug in the other point, we get negative 6 is equal to negative 1 cubed is negative 1. Negative 1 squared is positive 1, so it becomes plus a. and then becomes minus b minus 3. So then we can write this as, if it'll be a minus 4 on the right-hand side, so we add 4 minus 2 is equal to a plus a minus b, sorry. So we add these two equations together, what do we get? We get 4 is equal to 2a, so a is equal to 2, and now we can just plug into either one of the two equations I underlined. So b is equal to, it will be 6 minus 2, which is 4. So then 2a plus 2a plus b would just be 4 plus 4, which is 8. Okay? F of x is this cubic function. F of minus 2 is, you just plug in. Simple as that. It'll be negative 2 cubed minus 2 times negative 3 minus 1, which is negative 8 plus 6 minus 1, which is negative 2 minus 1, which is, I did something wrong because I don't have a choice there. Negative 2 cubed is negative 8 for sure. So this is a 2, that's why. Okay, so then this is a plus 4. So this becomes a minus 4 minus 1, which is negative 5. There we go. Okay. What is the domain of x minus 5 over x squared plus 25? Well, in the rational function, the denominator cannot be 0. This is never 0 because, well, if we even solve for x, there's no real solutions to this guy, right? It'll have to be complex. So there's no other restriction, so answer is D, all real numbers. Okay, this is the one that the website is wrong about. Okay, so the domain of this guy. Well, we have two restrictions. We first need to get this to be defined, the square root to be defined, and that is when the inside of the square root is greater than or equal to 0. This is a must. You can take the square root of 0, that's totally fine. If we take the square of a negative number, that will give us I and stuff like that, if you remember. So if we solve for x in this inequality, x is greater than or equal to 3, condition 1, okay? And then we also have, similar to number 5, the bottom, x squared minus 2x, cannot be equal to 0. If we factor this, we get x times x minus 2 cannot be 0. So x cannot be 0, and x cannot be 2. Okay, so I believe the website says choice B, but let's think about it. This condition, x is greater than or equal to 3, already includes these two as well. Because x cannot be 0 if x is greater than or equal to 3, and x cannot be negative 2 if x is greater than or equal to 3, right? X cannot be 2. Did I say negative 2? X cannot be 2 when x is greater than or equal to negative 3. So actually the best answer is choice C. X is greater than or equal to 3. Because again, this one condition already includes these two other conditions or exclusions, whatever you want to call it, okay? All right. We want to find F inverse for this guy. How do we do that? We swap the y and the x. And we solve for y. So what do? We do x divided by 4 is e to the 3y minus 9. We natural log both sides, so ln of x over 4 is equal to 3y minus 9. So natural log of x over 4 plus 9, and we multiply by a third, that will give us a y, which is our F inverse. So which one is that? That is choice A. Okay, number 8, we got to, looks like, expand this log. So what do? Well, we can rewrite this cube root as a power. It's to the 1/3 power. And by properties of logs, we can pull that power out in front. So a third log a squared b over c. And then next property we want to use, log of something divided by something is a difference. Log a squared b minus log of c. And finally, the log of a product of two things, you can make it a sum. So it becomes log a squared plus log b minus log C. And one more thing, once again, we can pull this power out in front. So it'll become 2 log of A instead of log of A squared. They're equivalent. Okay. So which one is it's C, right? All right. And then number 9, identify the vertical asymptotes of this guy. The vertical asymptotes are when the denominator is 0 for rational functions. So x squared minus 4 over, let's factor out x squared. So it'll be x plus 2. But actually, the top we can factor as well. So you got to be careful. It's x plus 2, x minus 2 on the top, right? So this x plus 2 is actually a whole. So the only vertical asymptote is when x is 0. The x is negative 2 is a whole. Removable discontinuity is not a asymptote, not infinite discontinuity. These are calculus terms I'm trying to use, okay? All right. That's it for this video. Hopefully this is good practice. Everything is pretty much fair game except the matrices, again, as of filming of this video. So if you got some wrong, you identify what you need to maybe brush up on or practice up on. So that's a good thing, actually, especially if you're preparing for the AP exam this time. Okay. All right. Hopefully see you in another video as well. Bye.